This is 7-6, number 2. We have to know what quadrants our half angles are in. I go into detail for all of the quadrants of the half angles, given where the original angle is. I go into that for the video for 7-6, question 3. I'll just do the one quadrant that we need for this one. So our original, let's find the quadrant of the original angle so we know our sign, plus or minus. Secant is equal to 4. Well, secant goes along with cosine. So secant is positive in the first and fourth quadrants, and then sine is positive, it says greater than 0. That quadrant's out. We're in the first quadrant. All right, let's just find our signs for the half angles right away, and then we'll do everything else we have to do. I will do this a little bit over here. So if our original angle is in quadrant 1, that means that 0 is less than theta is less than 90. That's quadrant 1. And we want to find where the half angle would be. So 0 is less than theta over 2 is less than 45. So that's still in quadrant 1. So if our original angle is quadrant 1, our half angle is in quadrant 1, and that means the sine and cosine of the half angles will both be positive. So I'll just write those there. So now we know the signs of both sine of theta over 2 and cosine of theta over 2. We'll use the positive square root formula. Now let's see if we can find the sine and cosine. Secant is equal to 4. That means cosine is equal to 1 over 4. It's the reciprocal. So let's draw our triangle. We don't have to worry about positive or negative signs here because we know whether the actual functions are positive or negative. There's theta. Cosine is 1 over 4. So 1 over 4. What does that make the other leg? Well, 1 squared plus x squared equals 16. X equals square root 16 minus 1. I subtract 1 squared from both sides, and then I take the square root. So x equals the square root 15. So that goes here. And again, we know the original angle is in the first quadrant, so sine and cosine are both positive. Sine is going to be square root of 15 over 4. So now we have what we need for our half angle and double angle formulas. Let's calculate them. Let's do A. Sine of 2 pi. Look it up if you would like to. It is going to be 2 times sine of pi, which is square root of 15 over 4, times cosine of pi, which is 1/4. The sign positive or negative of this takes care of itself, so long as you get these signs right. So you have to know what quadrant the original angle is. So 2 square root of 15 we're just multiplying, divided by 16, and that equals square root of 15 over 8. That's A, sine of 2 theta. So here is B, is cosine of 2 theta, and we'll use, well, let's see. Let me look at them and see which one I would like to use. Cosine, we're in the half angles there. Cosine of 2 theta. I'll use 1 minus 2 sine squared theta. 1 minus 2 sine squared theta equals 1 minus 2 times square root 15 over 4 squared, and that equals 1 minus 2 times square root of 15 squared is 15. Square root of 4 squared is 16 equals 1 minus 30 over 16 equals 16 over 16 minus 30 over 16 equals minus 14 16ths equals minus 7. I'm dividing both by 2/8. Let's check it on the double angle calculator. These double angle and half angle calculators get the sign right for the double angles. Sometimes they get them wrong for the half angles. So you have to look at your quadrant of the original angle and know where your other angle is so you know the sign. Okay, -7/8. See, that one came out right. I always check it. I like to double check it. All right, let's see. I've got plenty of room. Now we have to have the sine of theta over 2. C is the sine of theta over 2, which is equal to square root, and we said it's positive. And what are the half angle formulas? If you don't remember them, let's look here. 1 minus cosine theta over 2. 1 minus cosine theta, 1/4. Oh, these are going to come out nice. I need a little break there between my minus sign and my division. 1 minus 1/4 over 2 equals the square root. 4/4 minus 1/4 is 3/4 over 2 equals the square root of 3/8. We've got it. Well, we might as well put it into the half angle calculator. Now remember, again, you cannot trust the sign of this for some reason. And if you look down, even the formulas, they don't have the minus square root. So we want the sine given secant is 4, and we're in the first quadrant, and we'll calculate it, and they give us square root 6 over 4. And wait a minute. Square root of 6 over 4. How do we get square root of 6 over 4? Did I do everything right? Secant is 4. Hold on, I might have made a mistake. And we want the sine of pi over 2. Did I have the right formula? Sine is 1 minus cosine, and cosine is 1/4. And we're in the first quadrant. Let's reset it. Secant is 4. We're in the first quadrant. Calculate. Square root of 6 over 4. All right, did I calculate this wrong? Let's double check our work. We have 1 minus cosine. Cosine is 1/4 divided by 2. 4/4 minus 1/4 is 3/4 divided by 2 is 3/8. I've gone somewhere wrong here. And their number, did I do it wrong here? Sine of u over 2 given secant u equals 4 in the first quadrant. They got square root of 6 over 4. I got square root of 3 over square root of 8. Oh, they rationalized the denominator. They multiplied, let's see if this works, times square root of 8 over square root of 8 equals square root of 24, because 3 times 8 is 24, divided by 8. And 24 is 4 times 6. Yeah, they just rationalized the denominator on this one. 24 is, I want a perfect square, 6 times 4 divided by 8. Square root of 4 is 2. Square root of 6 over 8, which is equal to square root of 6 over 4. Okay, so in that calculator, they rationalize the denominator. I don't know if you have to do that in your answer, but it did come out right. Now we have the cosine of pi over 2, which is d. And again, remember, when our original angle is in the first quadrant, our half angle is also in the first quadrant, which means we use the positive square root. And cosine half angle is 1 plus cosine theta. So we get 1 plus 1/4 over 2 equals 4/4 plus 1/4 is square root of 5/4 over 2 equals square root of 5 over 8. And again, maybe you can put it just like that if you want to rationalize the denominator. I'll do it on this one because it comes out pretty simple. I don't do it on some other ones because it gets pretty complicated. And I can't find my scroll. Wait a minute. We have to find our scroll. So 5 times 8 is 40, so that's the square root of 40 over 8. And 40 is square root of 4 times 10 over 8. And that gives us 2 square root of 10 over 8. And that gives us square root of 10 over 4. And let's check it in our calculator. Remember again, this calculator gets these right. It gets the sign of the half angles wrong sometimes, so you have to make sure you know what quadrant the half angle is. I think this one just turns out right because it just spits them out all positive. So we get square root of 10 over 4. So that's it. We've done our 4. We found our quadrant for the half angles so that we knew the signs were positive, and then we double checked it in the calculator. We did all of them. That's 7.6, number 2.